Okay, worded question. Always think not just which is the right answer, why the other one's wrong. Let's have a look at A first. All right, A says the maximum value in a data set can never be negative. Can never be negative? Well, look, here's a data set, -3, -2, -1. The maximum value there is -1. That is definitely possible. Let's look at B. B, Pearson correlation coefficient, that is R. And we know that goes from 0 to -1 to 1. Therefore, it can definitely be negative. That whole half of the thing there is negative. The value of a moving mean in a smooth time series. Now, that might freak a few people out. But moving mean in a smooth time series. Well, again, if your data set contains only negative values, for the same reason that A can be negative, the same reason that C it can be negative. If I was to smooth out the values of -3, -2, -1, I might choose -2 as my middle one. You can see it is entirely possible. Seasonal index. That is actually the correct answer. Seasonal index, because you're always dividing things. But if you're not sure about these things, what I always do is I go, I think question mark on D. I'm definitely sure about A, B, and C. Let me have a look at E. It says E says the value of the slope of a least squares line fitted to a scatter plot. There you go. The slope is negative. So you can definitely have negatives there. And that can sort of reassure you a lot with these things. But if you're calculating seasonal index, you'll find that it is entirely possible, entirely impossible to get a negative value. Look at the formula. So let's look at the game of a seasonal. So seasonal index equals the value for the season divided by the average. Now, you might be thinking, hang on a minute, you could still have negative values for the season. But remember, if you've got a negative divided by, the average will still be negative then. So that'd be a negative divided by a negative, gives you a positive. Or the values for the season are positive and the average is positive. So positive divided by positive is positive. There is no way. Seasonal indices are, well, the average one is the rule for them. So they're only above and below 1, but they're never below 0. So that's the reason why that one works. But again, look at the strategy of A, B, and C. I know are definitely wrong. Must be D. Elimination is a very good technique. Okay, very big wordy question, but most people got this one right. So there you go. Not everyone's freaked out by wordy questions. So it says we've got data collected over a 10-year period. You've got an R of 0.87, which connects stray cats with stray dogs. But you've also got a correlation between population of the city and stray cats, and also population of the city again, and number of stray dogs, which is 0.72. So let's have a look at A and see what's the right answer for this. If cat owners paid more attention to keeping dogs off their property, the number of stray cats, that's just gibberish. That's just being a silly one. The association between the number of stray cats and stray dogs reported cannot be causal because only a correlation of +1 or -1 shows causal relationships. No. Causal relationships, I mean, +1, -1, that, if anyone gets that in a data set, it's freaky weird. Normally you'll be expecting something to be strong or moderate or weak. It can be much lower values than that, and much more realistic and natural to happen. C, there is no logical explanation for the association. It must be a chance occurrence. Well, yeah, it can't rule that out. So it can't, I mean, there might be, or there is no evidence to the contrary. It says D, because larger populations tend to have both a larger number of stray cats and stray dogs, the association between the number of stray cats and the number of stray dogs can be explained by a common response to a third variable, which is the increasing population size of the city. That looks pretty good. Again, here's my little question mark technique, because you always feel a bit sort of freaked out in exams. Let's look at E. More stray cats are reported because people are no longer as careful about keeping their cats properly. Oh, it's a silly answer, a bit like A, isn't it? And that's what we're really saying. Like, if you look at stray cats and stray dogs always going up over a period of 10 years, what they're really saying is it didn't go up. One causing the other. It's not stray cats are causing stray dogs or stray dogs are causing stray cats. It's the fact that in the same time the population of the city was increasing. We can see that with those other two correlations. It is definitely the answer D. But a lot of people didn't get that one wrong. So well done to those people. Okay, this is actually one that was done quite badly. Now, if we look at this, seasonality was the first problem people had. Look, if this is days, then we're showing 3 weeks, right? So you're actually saying like, well, there's a week here, and there's a week here, and there's a week here. Now, do they look similar patterns? No. So not seasonality. You can have seasonality that doesn't necessarily have to follow sort of seasons of summer, spring, autumn, winter sort of thing, but it does need to sort of regularly have those peaks and troughs that coincide with something like weeks or months or the actual seasons themselves. So it looks like irregular fluctuations only. I'm going to put my little question mark against that. It's quite a possibility. See, seasonality with irregular fluctuations. These two words, seasonality and irregular fluctuations, they contradict each other. You can't be seasonal and irregular. The whole point, seasonality is a regular pattern that you identify, so definitely not C. A decreasing trend. Can you see anything looking down? I mean, is it wiggling down? No. And for the same reason, an increasing trend. So that might be like you can see a trend like this and the fluctuations are going up like this. No. Look, this is just irregular. So the answer is B. But that one was done quite badly. A lot of people thought because it's going up and down within some sort of limits, because you've got that sort of up and down, and you've got regular troughs and regular peaks, but up and down to some sort of limits, but not within a week or within a month or a season or whatever it is that they're actually asking on the timescale. So a lot of people got sucked in and got that one wrong. Okay, so doing 7 median smooth. Median smooth, that means you're going to do it on the graph, and we need day 4. So I'm going to say this is 1, 2, 3, 4. So that's my 4. And so that's going to be 7. So we go to 5, 6, 7. So let me just maybe switch to the highlighter there. So we're looking at this, 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 and this, and this. And what you got to do with 7 is, well, you got to think there's three numbers at the top and 3 numbers at the bottom. So I can eliminate. That's my top 1, top 2, top 3, and from the bottom, top 1. Bottom 1, sorry, bottom 2, bottom 3, it is this value here. Okay, so we're going 3 up, 3 down, that's the one in the middle. That looks like to me it's 30, which is in fact the correct answer. Okay, so we need to be doing 4-point moving mean, and that is for day 11. And it says closest to as well, so that's something to pay attention to. But I'm going to do this in 2 colors to show you something. So we're looking at day 11 over here. So there is 4 numbers. We've got to look at these 4 numbers, and the middle of that distance from here to here is this point, and that's to the left of 11. So we've got to work out that average. So it's 22 plus 19 plus 22 plus 43, all that over 4, and that gets you 26.5. Now, in an entirely different color, we could look at the average of these 4 numbers, and we can see it looks like this, and that's to the right of 11. And if we add up those numbers, we've got 19 plus 22 plus 43 plus 37. Divide that by 4, that equals 30.25, or 13.25. So we have got a point to the left of 11, a point to the right of 11. We've got to take the average of this one and this one. So we do 26.5 plus 30.25, divide that by 2, and you'll get 28.3. 0.375 or 3/8 if you know what you're talking about. And that's just saying like, okay, I'm on the left here, and then I'm on the right here, and if I smooth and find the middle point, it is this number down here, 28.375. Quite clearly, that is closest to 28. It looks like that freaked out a few people on the exam, and they just guessed and went, oh, 22, I don't know, because it's near 22, or maybe the 43s pulled it up a bit higher, but there seems to be a few people who guessed on that one. 4-point smoothing mean. Can you see we've got one where the numbers are a bit below, so we got the red set of numbers, and then ones that are a bit above, we've got the light blue numbers, and then we're going to average those out to find that middle point in between the red and the light blue lines. Okay, this is a question that was done badly, but let's just think about what it means first of all. So think about this, cold drinks in January. You're going to sell a lot of cold drinks in January or only a few? Since we're in the southern hemisphere, we are going to say we're going to sell a lot of them. Now the whole point of a seasonal index is that, say, this is your average. If you've got here, say that this is January sort of thing, and this is in the middle of the year, so June, and then you got your December over here sort of thing. You can imagine that your drink sales are quite high in January, above the average, and then they go down and they go back up again, right? This is your average here. So we want to bring those values down because we expect to sell a lot in January, whereas in winter we'd expect to bring them up. And again, by the time we get to December, we're back down again. So we're going to be thinking it's going to be decreasing, right? So you've got to reduce your sales figures to bring them down to the average. That rules out D and E. And again, look at that 60%, because people think 1.6, 60%, dearie me. And we can probably smell the rotten egg there as well, reduced by 40%, because it only goes, oh, 1.6, I don't know, 40%, 60. No, let's be sensible about this. If we look at the idea of seasonal index, so de-seasonalized have I spelled that right? Value is the actual over the seasonal index. No, we don't know what our number actual is, but let me just erase that and get some space. So if we think about this, if we just had 100% of our sales and we divided by 1.6, we would end up with 62.5. Okay, so you think C? No! We started at 100. Where did we start? We started at 100 and we went down to 62.5. So how do we get from 100 down to 62.5? We went down 37.5%. All right, so 37.5%. A lot of people sort of did the 100 divided by 1.6 and then chose C, sucked in. So we started with 100, we went down to 62.5. What's the difference between those two numbers? 37.5. The correct answer was A. Do have a look at those questions. Think about the logical thing of what they're selling and when they're selling it, because that might sort of help you sort of at least eliminate like D and E in this case, or any stupid other sort of simple answers, which is like your 60% and your 40%, because it's not that